Describing homeostasis, we could say that homeostasis describes an organism maintaining a constant or a consistent internal environment, or a stable internal environment, in an ever-changing external environment. Or we could say despite external changes or stimuli. Now, here's an example. Normal body temperature is close to 98.7 degrees Fahrenheit. And even if I walk out and it is 30 degrees Fahrenheit outside, my body should maintain an internal temperature close to 98.7 degrees Fahrenheit. Or blood glucose levels. Blood glucose levels should be maintained at relatively constant range, or at a relatively constant range, even if I eat a candy bar, or a turkey sandwich, or salad, or exercise. Okay? That's an example of a changing external environment or a stimulus delivered to an organism, and yet a constant internal environment is maintained. And we'll talk about throughout this class and advanced anatomy and physiology how homeostasis is maintained. Now, generically speaking, we have two main mechanisms to maintain homeostasis. We have negative and positive feedback loops. Now, don't mistake negative for being bad. Negative in this case doesn't mean bad, and positive doesn't mean good. Okay? So separate yourself from that particular thinking. In a negative feedback loop, we have a constant or a relatively constant variable, like body temperature at 98.7 degrees. And we go out into the cold, and as a result of the cold, our body temperature may temporarily or theoretically lower just a little bit. Let's say it goes down to 98.5 degrees. What does the body do, or what can an organism do to return back to 98.7 degrees? Well, it can shiver, right? That's a good example. And by shivering, body temperature is then returned or maintained at 98.7 degrees Fahrenheit. We've deviated from the set point, and then we have a response that returns us back to that set point. This is a negative feedback loop, or an example of a negative feedback loop. Let me provide another negative feedback loop example for you. I have my blood glucose level, and I eat a candy bar, and it is elevated. And after my blood glucose begins to elevate, I release a hormone called insulin, which reduces my blood glucose back to normal. That's another example of a negative feedback loop. I deviate from normal, and I generate a response that returns back to normal, or returns that variable back to normal. We'll talk about components of a feedback loop in just a little bit. Positive feedback loops are altogether different. In a positive feedback loop, I have a stimulus, or I have a normal condition. Let's say I have the normal tone of the uterus. I don't have a uterus, but many of you probably do. So we have a normal uterus, but that normal uterus is pregnant, and it is ready to deliver a baby. And so as a result of the beginning of labor, there is stretch on the uterus, and there are other hormonal factors that begin to cause muscular contractions of the uterus. And as a result of those muscular contractions, a hormone is released called oxytocin. And oxytocin causes more muscular contractions, which causes a hormone to be released called oxytocin, which causes muscular contractions. And you can see that we go from normal, away from normal, further away from normal, further away from normal, further away from normal, or I should say a set point, until finally we have delivery of a baby, right? As we continue to progress away from normal, we still have a feedback loop, but it's called a positive feedback loop. Doesn't mean it's good or bad. It just means that we continue to deviate from a set point. Now, classically speaking, it's the negative feedback loops that are most responsible for the continual and the ordinary maintenance of homeostasis. However, occasionally positive feedback loops do result in homeostasis being maintained as well. A good example would be blood clotting mechanisms. Those rely on positive feedback loops until a clot is formed and bleeding stops, or hemostasis results. Another example of a positive feedback loop that is indeed a bad thing is a reaction called an anaphylactic reaction, the result of a bee sting, which causes excessive swelling and inflammation, which progresses and progresses and progresses until eventually, if not treated, could result in death. Okay. Most of the examples that you'll think of involve negative feedback loops, maintaining body temperature, maintaining cardiac output, maintaining heart rate, maintaining blood glucose, maintaining blood calcium levels, maintaining pH. Those are all examples of items that are mostly regulated via negative feedback loops. Let's talk one last minute about mechanisms of these feedback loops, or parts of a feedback loop. Parts of a feedback loop generically include a receptor, 2, a control center, and 3, what we call an effector. Let's talk about that example where we go out into the cold. Those receptors are called cold or thermoreceptors, but we'll call them cold receptors. They send messages to the brain and they say, hey, it's cold. So the control center is the brain, generically. And the brain tells muscles to shiver. So those muscles are the effector. And the muscles, when they shiver, they return the body back to normal temperature. So we have a receptor, a control center, and an effector. Now, all feedback loops have these 3 components. Both positive and negative feedback loops have these components. All right. I hope you can use this lecture as a little bit of a preview for what we're in for the rest of our anatomy and physiology class. I hope that it helps you, and if you have any questions, please let me know. I'm here to help you. Have a great day.